One starts back in 1929 when the great astronomer Edwin Hubble realized that the distant galaxies were all rushing away from us, establishing that space itself is stretching, it's expanding. Now, this was revolutionary. The prevailing wisdom was that on the largest of scales, the universe was static. But even so, there was one thing that everyone was certain of. The expansion must be slowing down. That is, much as the gravitational pull of the Earth slows the ascent of an apple tossed upward, the gravitational pull of each galaxy on every other must be slowing the expansion of space. Now let's fast forward to the 1990s, when those two teams of astronomers I mentioned at the outset were inspired by this reasoning to measure the rate at which the expansion has been slowing. And they did this by painstaking observations of numerous distant galaxies, allowing them to chart how the expansion rate has changed over time. Here's the surprise. They found that the expansion is not slowing down. Instead, they found that it's speeding up, going faster and faster. That's like tossing an apple upward, and it goes up faster and faster. Now, if you saw an apple do that, you'd want to know why. What's pushing on it? Similarly, the astronomers' results are surely well deserving of the Nobel Prize, but they raised an analogous question. What force is driving all galaxies to rush away from every other at an ever-quickening speed? Well, the most promising answer comes from an old idea of Einstein's. You see, we are all used to gravity being a force that does one thing: pulls objects together. But in Einstein's theory of gravity, his general theory of relativity, gravity can also push things apart. How? Well, according to Einstein's math, if space is uniformly filled with an invisible energy, sort of like a uniform invisible mist, then the gravity generated by that mist would be repulsive. Repulsive gravity, which is just what we need to explain the observations, because the repulsive gravity of an invisible energy in space, we now call it dark energy, but I've made it smoky white here so you can see it. Its repulsive gravity would cause each galaxy to push against every other, driving the expansion to speed up, not slow down. And this explanation represents great progress. But I promise you a mystery.